Hi there, everyone. My name's Nicole Trammell. Thank you for tuning into our presentation. Our project is about fish passage projects in the Klamath River and specifically impacts on salmon and steelhead populations. Our group members were Andrew, Michael, Felicia, and myself, Nicole. This presentation is for our Environmental Science 498 course or senior seminar. Our professor's name is Kara Teague. So let's get started. Introduction. As I mentioned before, I'm Nicole and my fellow group members are Andrew, Michael, and Felicia. Our high-level focus was habitat loss, fragmentation, and connectivity. The specific focus is fish passage projects in the Klamath River Basin. So let's go ahead and define what fish passage means for the purpose of our project. It is the ability of fish to move freely for food, growth and reproduction, or other needs. This definition comes directly from the Interagency Fish Passage Portal. To get started, I'll talk about the importance of our project. Our project is important because there are currently 28 populations or population units of Pacific salmon and steelhead that are listed on the Endangered Species Act. Not all species were listed at the same time. Some were listed back in 1991 and others between the years of 2005 to 2007. This project is important because we are getting ready to head into 2026 and these species are still listed on the ESA, which means that not much population recuperation has occurred. The strongest method to try and get species delisted is by creating recovery plans to be implemented. Talking about fish passage projects on the Klamath River is important because historically, the Klamath River has been one of the most important salmon rivers in the Pacific Northwest. This river historically has been known to not only support healthy populations, but also been key to the migration of salmon and steelhead to and from the ocean depending on spawn cycles. One study that was conducted in the Chehalis River Basin monitored several species of steelheads and salmon. During this study, one of the key findings was that increasing both habitat productivity and habitat capacity led to higher survival rates. Another key finding was that cooler temperature water climates helped some populations even when no restoration efforts occurred. This means that salmon are good indicators of climate change and changing water temperatures because they are species that thrive and reproduce in cooler temperature waters. As climate changes happen, water becomes warmer, thus affecting salmon and steelhead species. A concept that I would like to introduce is called salmon strongholds. The idea behind a salmon stronghold is to focus conservation efforts to areas that currently support salmon populations instead of spreading resources too thin and focusing on restoring habitats that do not currently support these species. In the same article that creates the idea of salmon strongholds, a modeling tool called Habitat Restoration and Planning, or the HARP tool, was used to evaluate if habitat restoration makes the salmonoid species more resistant to changing climate conditions. A key finding from the study was that increasing both habitat productivity and habitat capacity led to higher survival rates. A focus point of the salmon stronghold is to focus on strong local and federal agency leadership to help foster proactive habitat protection and restoration. By doing so, this helps maintain biodiversity and strengthens carrying capacities. Fish passage portals specifically on the Klamath River are extremely important because these projects will help restore access to colder temperature waters. It will reconnect historical habitats, and the projects will also help improve the life history and genetic diversities of these salmonoid species. Throughout our project, my fellow group members will help to address some key points of our group project. Some of the key points to be discussed will be about the Klamath River reconnection efforts, river and flow fragmentation, the reconnection of waterways throughout the Klamath River, project funding and critical projects will be discussed, as well as fish passage barrier removals. Tools used for data collection. One of the main tools that we used throughout our project planning stages was the Interagency Fish Passage Portal. Many of you may already be familiar with this site, but in the event you are not familiar with it, I'll explain a bit about it. This website helps provide information of fish passage projects and connectivity projects. The goal of the portal is for coordination and collaboration between state and federal agencies. It has helped raise awareness of fish passage problems and projects that are currently happening. For the purpose of our presentation, we focus primarily on the Klamath River Basin. There were also other tools my group members and myself used to find scholarly articles related to our project. A major one was the Treffery Library provided through American Public University and Google Scholar. Conversations were also had with ChatGPT to vet and select sources to be used. And now I'll go ahead and pass the mic off to one of my fellow group members.
Hey, how's it going, class? I'm Andrew Ferraro. I hope everybody's having great holidays so far and continues to. I'll be covering a middle portion of the Klamath River project slideshow that Group 3 created. So this project examines how reconnecting the Klamath River is restoring migration routes and habitat loss for Pacific salmon and steelhead, which have been heavily affected by dams, culverts, and water diversions. The focus is on how barriers fragmented the river, how the fragmentation contributed to aquatic habitat loss, and how current fish passage projects such as dam removal and culvert replacement are reopening access to historic spawning rearing areas. So this project is pretty much talking about, like it mentioned, the removal of man-made objects for the most part, such as dam and culverts that are going to create shallow areas and areas where fish can actually get trapped and not be able to spawn correctly. So let's go. River fragmentation. River fragmentation happens when dams, road crossings, and water diversions chop a river into isolated segments instead of one connected system. For anadromous fish like the coho salmon and steelhead trout, fragmentation breaks a migration corridor between the ocean, mainstream Klamath, and upstream spawning and rearing habitats. Klamath dams block salmon and steelhead for more than 400 miles of historical habitat, concentrating fish below dams and cutting them off from colder upstream tributaries. This caused low flows and warm reservoir altered condition below dam, contributing to fish deaths and disease outbreaks such as a 2002 event when tens of thousands of adult salmon died below Iron Gate Dam. So as mentioned, this project's sole focus is removing those and reconnecting the whole river pretty much to its natural form. Natural after it gets worked on and the dams and culverts removed, so that fish can flow freely to and from spawning areas without the fear of getting trapped or creating predatory areas where they could easily get preyed on. Diversion and flow fragmentation. The combination of culverts, dams, and small barriers cause irrigation and other water diversions fragments within the habitat, severely reducing flows, creating shallow areas, side channels, and slows. Reduced warmer flows from diversions making migration more stressful, increased predation, and disease risk, and limit access to cold water refuges that salmon and steelhead need to survive droughts and heat waves. Reconnecting the Klamath matters. So we have a nice little map attached on the left side. Don't let it fool you. That is 420 miles that we'll talk about here. Ongoing dam removal and fish passage projects are reopening about 420 miles of river and cold water tributaries, giving salmon and steelhead access to much larger network of habitat across the basin. Restoring connectivity makes population more resilient by spreading fish across the tributaries, improving spawning success, and helping them adapt to climate-driven changes in temperature and flow. So interagency fish portal. Sorry, it's a mouthful. The Interagency Fish Portal is a national online one-stop shop that brings together data and tools from multiple federal agencies to support planning and funding of fish passage and aquatic connectivity projects. It is designed so managers, tribes, NGOs, and researchers can quickly find where barriers are, what work has already been done, and what funding or technical resources are available to improve passage. So it's basically just a web-based hub where everybody can look what projects are being executed, have been executed, or potentially even planned on being executed, or what should be done. So all agencies can do that. The Department of Interior covers a lot of agencies such as Fish and Wildlife, NOAA, Park Services, all them. So they all don't always talk to each other constantly. Just sort of like the military, that we don't always talk to each other. So it's nice to have somewhere that you could go to, look if a project's being done, and if it is being done, track the progress of it. So projects and funding. In the Klamath River Basin, $24.3 million have been allocated to address 10 fish projects. These projects were managed by U.S. Fish and Wildlife Services, NOAA, U.S. Forest Services, and the Bureau of Reclamation. These agencies worked in partnership with local government. As we talked about before, all those agencies can plug in their information in this fish portal, then people can track what each other are doing, so nothing gets lost in the mix. Being in a project planning environment like I am, more stuff gets lost than you'd think. Someone just closed out a project, and if someone rolls in after me, they have no clue what I did, why I did it, or how I did it. So having an actual portal for this is a very good idea, and I'm sure it's very useful, and from what we've looked through, it is very useful. Yeah, so the Interagency Fish Portal project data. Project types. We have multiple different project types. One being the Aquatic Organism Passage, or AOP, which is a majority, which is shared with Bridge. That's 21%. Then you have barrier removal, which is 7%. Bridge, as we mentioned, also 21%. Culvert, 14%. Design, 7%. Fish screen, 7%. Floodplain restoration, 7%, and various others, 14%. Mainly what we talked about through our whole project was the dam removal and culvert removal that was creating an issue for the fish passage in spawning areas for the salmon and steelhead. This website, or the fish passage portal, covers a lot more than that, so I recommend everybody to check it out, and it was definitely helpful for what we needed from our project. I'll now be passing it on to another group member. Hope everyone's having a great day.
Previous slides, there are many organizations such as the BLM, Bureau of Reclamation, Department of Energy, and the Federal Highway Administration that are contributing to the fish passage projects. The three critical projects focused on using the integrated fish passage portal was the Pomeroy Dam Removal Project, the Bear Creek Fish Passage Burial Removal, and the Keno Dam Fish Pass Project. Pomeroy Dam removal involved removing a small aging dam on the river that restored the natural process for key species and improved the overall ecosystem. This dam blocked fish passage that limited access to critical spawning and rearing habitat for salmon and steelhead species. Once the dam was removed, it allowed the river to flow more free and restored over 100 miles of key habitat, which has helped in improving habitat population resilience and allowing more species to start using this area. Removing this dam also improved gravel beds in the river, which helped improve the habitat for aquatic organisms. The Bear Creek Fish Passage Burial Removal Project focused on improving stream connectivity by removing undersized culverts, small dams, and road crossings, which restricted the movement for salmon and steelhead species. These obstacles prevented species from getting access to key habitat that was used for spawning, rearing, and seasonal migration. By removing the structural barriers, this project restored many miles of upstream habitat, which restored the natural flow of the Bear Creek. Salmon and steelhead were allowed to move freely throughout the watershed. This has increased habitat, overall population growth, and resilience. This project has shown a successful, cost-effective restoration project that has created a healthier aquatic ecosystem, has strengthened fish populations, and has improved the long-term watershed stability for salmon and steelhead species. Fish Pass project was created to improve fish movement past Keno Dam on the Klamath River. This dam was acting as a barrier for salmon and steelhead, which limited access to spawning and rearing habitats. This project did not remove the dam, but focused on creating ladders that allowed salmon and steelhead to safely migrate around the dam. The Keno Dam project has reduced migration delays, lowered fish stress and mortality rates, and has improved the overall population recovery for salmon and steelhead. The Keno Dam Fish Project, done by the U.S. Bureau of Reclamation, improved fish passage for salmon and steelhead species and restored 420 miles of upstream habitat by creating fish ladders. The Pomeroy Dam Removal Project, done by the U.S. Fish and Wildlife Service, fully reconnected the Klamath River by removing the dam. The natural floor was restored, which has improved habitat quality and has increased upstream spawning and rearing areas for 100 miles of key habitat for salmon and steelhead species. The Bear Creek Fish Removal Project focused on a smaller scale benefits for salmon and steelhead, restoring 3 to 8 miles of habitat. By removing culverts and allowing access to be reopened, this restored access to habitat, which has shown improvements in salmon and steelhead populations. The agency created this was the Rogue Valley Council of Governments. Collectively, these three projects show that whether a full dam removal or targeted passage improvements, restoring connectivity is a key factor in supporting fish recovery and overall river health.
Good evening, everyone. I'm Michael. I'm going to be wrapping up my group's presentation with the discussion and conclusion sections. So first and foremost, the Klamath River Basin is an excellent opportunity to examine the effects of these fish pass portals just because the amount of species that use this area and the amount of different environments there is within the river basin. You have small little tributaries as well as large dams, and all of these offer interesting insight on how fish pass portals affect the local species there. So we know that connectivity restoration increases population resilience. This allows fish to spread across multiple habitats rather than concentrating them in one area where they have to deal with increased stress, increased competition, warmer waters. So this also goes into combating the effects of climate change on these salmonoids and steelhead. As water gets warmer, they need to go farther upstream to get to colder water. So it's very important that there aren't barriers in the way that block them from going upstream. Scientific studies show that it also increases diversity, allowing these animals to have access to larger areas. And this is something that we've seen in all of our literature reviews when reading reports from federal agencies and identifying those reports using the Fish Pass portal. So the Klamath River Basin has a really interesting history of coordinated efforts to restore those environments. As you've seen in this presentation from the different projects that we've shown, A lot of different agencies are working together, doing a lot of different types of projects in order to restore these areas and to remove barriers to allow those fish to have access to their historical spawning areas. All right, the 3 projects that we chose to highlight most. The reason why we chose these 3 different projects is because they do such a good job of showing that diversity that I was discussing. So first we have the Keno Dam Fish Pass Portal. That showed how you could instantly reconnect habitats with dam removal. Obviously, due to economic reasons, due to cultural or even geographic reasons, you cannot always just remove a dam. So there are other things that we have found can be effective as well. Things like what we saw at the, I meant to talk about the Pomeroy Dam removal. I said the Keno Dam removal. So the Pomeroy Dam removal is an example of reconnecting those environments through just removing a dam. Now the Keno Dam Fish Pass Portal shows how you can reconnect those environments without necessarily having to remove that entire dam. They were able to install a fish ladder, which was found out originally not to be effective specifically for the Pacific salmon. There was issues where they were not able to pass through that ladder. So that is what they're doing now, improving that ladder. So the dam is still there and it allows for partial connectivity. So fish can still access the upstream environments without the dam having to be completely removed. In addition to that, we talked about the Bear Creek burial removal. So that is removing little barriers like culverts, things that are blocking the fish's access to tributaries, those smaller waterways, which are crucial in order for them to spread out, reduce the risk of disease or increase stress of competition being stuck in a little area. So this shows all across the gambit there what are important types of fish pass portals, whether it's something huge like the Pomeroy Dam removal, where we're instantly reconnecting 100 if not more miles of habitat, or that Keno Dam where we're using alternate methods to allow fish to pass that dam, connecting, I believe it is 420 miles of upstream habitats, or even something smaller scale like those Bear Creek barrier removals. All right, so what can we conclude from analyzing the literature, analyzing the Fish Pass portal, diving into the data that it has provided us? We can conclude that these efforts have significantly improved habitat connectivity for Pacific salmon, steelhead, and other species alike. Hundreds of miles of habitat have been reconnected through dam removals, culvert replacements, passage improvements. Now fish have access to their historical spawning grounds. They're not as susceptible to stress and competition. They're not as likely to die of disease because they'll be able to be more genetically diverse by entering these areas and having more breeding opportunities. The fish in question here, the Pacific salmon and steelhead, some populations are threatened or endangered. In general, the populations are strong, but there are pockets within the United States and within these river systems that are specifically threatened. Some of them being here in the Klamath River Basin. So these efforts have been directly effective in bringing them closer to recovery. So the literature shows that habitat fragmentation is a major threat to salmonoids, to steelhead, and combating that is critical in protecting ecosystems, protecting diversity, and major progress has been made. But the Klamath River Basin demonstrates how coordinated science-based restoration can support the recovery of these threatened species. While a lot of progress has been made, there's always still room for more. So there are more technologies coming along, things that even are like shooting fish through tubes to go through different barriers. More and creative technologies are arriving, and that is something that conservationists should continue to look forward to kind of solve some of those sticky situations that they might have in the future. As of now, what we've seen, what we've studied along this presentation is that there are very effective steps being made within the Klamath River Basin to recover these species and to just generally improve interconnectivity.